Hey everyone, welcome to EasyChem videos back again to discuss the third video on reactions of carbonyl compound. We have discussed two more videos earlier, part 1 and part 2. You can visit these two sites. Part 1 can be found out in this URL, and part 2 video can be found out under this URL. Now, in this part 3, we are trying to discuss about a very special reaction of carbonyl compounds, that is to distinguish mainly methyl ketones. The reaction we are going to discuss today is triiodomethane or iodoform test. Before we go ahead with the lesson, you can think about a little bit. Please try to subscribe my channel and like. And at the same time, if you have any comment, you are free to come up with, and it will help me to improve the content that I'm given to in these videos. Now, the lesson, as I said earlier, is to talk about triiodomethane or iodoform test. Now, what is this triiodomethane? Iodoform or triiodomethane is a yellow compound, and it has the formula CHI3. You can see the color of this triiodomethane or iodoform. Now, not only the color, this triiodoform has a special feature. It has a faintly medical smell. Actually, it has some medical value. It is used on sticky plasters that you put on minor cuts because it's an antiseptic. You can think about a time in your life, you have used these sticky plasters. Now remember, the substance which is there to treat your wound is iodoform. If you think about the structure of the iodoform, you can have 3 iodine and 1 hydrogen atom attached to a single carbon atom in this triiodomethane or iodoform molecule, as you can see here. Now, this triiodomethane or iodoform test is mainly carried out to identify methyl ketones. A methyl ketone, they have a methyl group directly attached to carbonyl functional group, as you can see here. This is a carbonyl functional group. This carbonyl functional group is attached to a CH3 group on one side, and the other side an alkyl group. In for the discussion, I have taken a ketone molecule where both the sides have CH3, but we think about the presence of at least one CH3 group. And you can see the number of carbon atoms present in this molecule is 1, 2, 3. Therefore, the name of it, just to be familiar with the things that you have already learned, propanone. Let us take another compound. This compound has carbon number 1, carbon number 2, 3, and 4. It's a ketone. This ketone is butanone, and this is also a methyl ketone because we have CH3 group attached to carbonyl functional group. And at the same time, another example to just look at. Now, this compound has how many carbon atoms? 5 carbon atoms. It's a ketone. It is also a methyl ketone because we have CH3 group attached to carbonyl functional group. And it is pentan 2-1. In addition to these methyl ketones, there are some other compounds also which give positive test to iodoform reaction, and you should know it. First one is methyl secondary alcohols or methyl carbenols. Remember, methyl secondary alcohol. I'm going to show you the real structure of these methyl secondary alcohols in a while. And the third compound, which gives positive test for iodoform test, is ethanol. After ethanol, we have another compound, ethanol. Now, we talk about alcohol in the second point, methyl secondary alcohols. Now, the last one I have shown here as a fourth compound, which gives positive test for Iodoform test is ethanol. Ethanol is not a secondary alcohol, it is a primary alcohol. Remember, ethanol is the only primary alcohol that gives a positive test for iodoform test. We will go through the structures of these four types of compounds. You can see in yellow, methyl ketone. And then the second type of compound is actually a carbinol or secondary methyl alcohol. And you see the third compound is an aldehyde having 2 carbon atoms, so it is ethanol. And the last one is an alcohol, a primary alcohol, and we discussed this a little bit, earlier. It is ethanol. So what is important about this? Look at the ethanol and the ethanol. Ethanol is the only primary alcohol to show the iodoform test. And also, when you take ethanol, ethanol is the only aldehyde that can show iodoform test. And if you go further into this, we will see how methyl ketones undergo iodoform test. And to summarize, a methyl ketone produces triiodomethane, a yellow substance, and corresponding sodium carboxylate when heated with sodium hydroxide and iodine in a water bath. We carry out this experiment in a water bath because aldehydes and ketones are flammable. If you use naked flame to heat this reaction mixture, most probably this aldehyde or ketone will catch fire. Therefore, we use a water bath for this. So we call it wet heat as well. First example, we'll see under methyl ketone reaction with the iodoform test in iodoform test. First one is reaction of propanone, a 3-carbon containing molecule propanone. In this propanone molecule, we have a CH3 we can take left or right. However, CH3 group is attached to the carbonyl functional group. This compound, propanone, is going to react when heated with sodium hydroxide and iodine to produce sodium ethanoate and triiodomethane or iodoform. That's our main focus in our lesson. And when this reaction happens, there's something very, very important. You can see, look at the propanone molecule. This propanone molecule is having 3 carbon atoms. And then what happened to these 3 carbon atoms? You can see in sodium ethanoate, the number of carbon atoms is decreased to 2. So in this reaction, iodoform, 3 carbon atom molecule is going to produce a 2 carbon atom molecule. It means the carbon number decreases by 1. It is because this CH3 group is going to detach from the molecule to form triiodomethane. You can see the number of carbon atoms decreases by 1, something really important you must remember. And then we go to another ketone. This time it is butanone, 4-carbon containing ketone. See the structure. Here, on the right-hand side here, we have the methyl group directly attached to the carbonyl functional group. On the left-hand side, we have CH2CH3. It's not methyl group. We don't take this into consideration for the reaction. However, this butanone is going to react, of course, when you heat at the presence of sodium hydroxide and iodine to produce a compound, sodium propanoate. You can see the carbon number. In butanone, there are 4 carbon atoms, but in propanoate, here, sodium propanoate, we have only 3 carbon atoms. Why? This CH3 group gets detached, and it's going to produce the triiodomethane or iodoform in this reaction. So because of the removal of this CH3, I'm reiterating, the carbon number of the molecule decreases by 1. See, 4 carbon atoms on the left-hand side, the product has only 3 carbon atoms. You can think about another reaction. This time it is phenylethanol molecule. This phenylethanol molecule has a phenyl group. Phenyl group means benzene ring. We can construct the phenylethanol molecule step by step. The benzene ring gets a bond. And that bond is going to connect to this part. 2 carbon atoms are there in this part. So this is phenylethanol. Because we have CH3 group here, it also reacts in the same manner. When you heat at the presence of sodium hydroxide, you will see phenylethanol producing a molecule having 1 carbon atom lesser than the phenylethanol molecule. And compound is sodium benzoate. See the number of carbon atoms. The CH3 group has gone out and a sodium salt has been formed. And we can see our main focus, triiodomethane molecule has been formed. So it's very interesting to see always the CH3 group attached to functional group, carbonyl functional group, goes out in this manner. Now the 3 reactions we have discussed can be taken together in a single screen so that we can identify or we can study better about the nature of the reaction. You can see here, propanone goes to sodium ethanoate. This was our first example, producing triiodomethane. Similarly, butanone produces sodium propanoate, producing triiodomethane also. Phenylethanol react, giving sodium benzoate, plus triiodomethane. All have triiodomethane as a product. This triiodomethane is coming from CH3. Please remember, CH3 attached to carbonyl functional group. In propanone, we see CH3, and that part actually gets detached. In the second one, again, the CH3 part is going to make triiodomethane. How? The CH3 is getting detached from the molecule. And then in the third one as well, there's no difference. The same type of a reaction occurs. CH3 part comes out and it goes to triiodomethane and 1 carbon less product molecule. So it's about methyl ketone. Now, if we talk about how methyl secondary alcohols undergo iodoform test, what's the structure of a methyl secondary alcohol? Before that, we'll see. A methyl secondary alcohol form triiodomethane. Same thing. And corresponding sodium carboxylate. I'm repeating the same thing. When heated with sodium hydroxide iodine in a water bath. Think about the reason why we use a water bath, because otherwise alcohols can catch fire. What is this first compound? Reaction of propan-2-ol. You can see the propan-2-ol molecule. In this propan-2-ol molecule, in the middle, we have this carbon atom to which OH is attached. This carbon is alpha carbon. Alpha carbon is attached to a CH3 group. You can take the left side or right side CH3 group. Now, alpha carbon is attached to a CH3 group. So it is methyl alcohol. Methyl, and this carbon is attached to alkyl groups. So it is secondary alcohol. This is a methyl secondary alcohol. Methyl secondary alcohols also react when heated at the presence of sodium hydroxide and iodine to produce a sodium salt. Now see the carbon number in the sodium salt. Propan-2-ol has 3 carbon atoms. This product, sodium salt, sodium ethanoate, has only 2 carbon atoms. The CH3 part attached to the alpha carbon has gone out, and it is going to produce CH3I, in other words, triiodomethane. However, remember that this reaction is not happening in a single step. When you heat propan-2-ol with sodium hydroxide and iodine, before going to sodium ethanoate, sodium salt of a carboxylic acid, this propan 2-ol is going to change to make a ketone. And then this ketone is going to form sodium ethanoate. You know that this reaction is possible because this is a methyl ketone. If you see very clearly, there are two reactions happening. Both the reactions are happening at the presence of sodium hydroxide and iodine. Of course, heating has to be done. If you see the first reaction, propan 2-ol, first comes to propanol. What sort of a reaction is it? It is an oxidation. You can see very clearly this alpha carbon is attached to OH. Because it's a secondary alcohol, it also has a hydrogen atom. See the product. In the product, that OH has disappeared and one oxygen has come over here. Hydrogen has removed. Removal of hydrogen is oxidation. Not only this hydrogen which is attached to OH, the hydrogen attached to alpha carbon, it also has gone up. So this oxidation of propan 2-ol to make propanol happens at the presence of an oxidizing agent. The oxidizing agent is sodium OI, sodium hypaldehyde. Of course, in our syllabus, it is not very much necessary to remember this, but I'm introducing that also because it's an oxidation reaction. And an oxidation reaction happens at the presence of an oxidizing agent. If I don't give this, you might wonder sometime later that how is it possible for this oxidation reaction to happen without the involvement of an oxidizing agent. Now this NaOI oxidizing agent is produced within the system. No one is going to add it into the system. We have sodium hydroxide and iodine. They react, producing this oxidizing agent during the reaction. So this is how secondary methyl alcohols undergo iodoform test. Now we are left with two other things. Reaction of ethanol and reaction of ethanol under or in triiodomethane or iodoform test. How do ethanol and ethanol undergo iodoform test? We can discuss this in a single screen. First, about ethanol. Ethanol undergoes iodoform test forming triiodomethane and sodium methanoate. How is it possible? Okay, ethanol is having two carbon atoms. Sodium methanoate has only one carbon. Now, if I think about the first one, the reaction of ethanol, see the structure. This ethanol is the only aldehyde which can have CH3 group attached to the carbonyl function group. No other aldehyde has this feature. This one can react with, again, when heated at the presence of sodium hydroxide and iodine to make, now see the compound has only one carbon atom, sodium methanoate. Product has two carbon atoms. So when this ethanol undergoes this iodoform test to make ethanol, sodium methanoate, the CH3 part has gone out and it has converted to iodoform or triiodomethane. It's a pretty simple, straightforward reaction. Afterwards, we go to the next one, reaction of ethanol. Remember I told at the beginning, this ethanol is only alcohol, primary alcohol, in fact, primary alcohol, which can undergo iodoform test. And here also, it's not a big deal. See, ethanol also undergoes iodoform test, forming triiodomethane and sodium methanoate. It's the same thing happened in this one also, because ethanol has two carbon atoms. Ethanol also has two carbon atoms. They are both going to produce the same product mixture. When you heat ethanol at the presence of sodium hydroxide and iodine in a water bath, you can get sodium methanoate and triiodomethane. Now, likewise, we can talk about how 4 different compounds undergo iodoform test. But then afterwards, we got to think a little bit as to why are we talking about this iodoform test? Because there's an importance. There are 2 things I want to talk about. First one, this iodoform test is going to help us to distinguish compounds. What compounds? Already I have told you. First one is methyl ketones. A structure has come onto the screen. Methyl ketone. Don't think about this R group. It can be anything. The most important thing is there's a CH3 group attached to carbonyl functional group. Don't forget it. And then we got the next one. It is ethanol. This is the third one I discussed in the lesson. Ethanol, see the structure of ethanol. Ethanol is the only aldehyde which uses iodoform test because it has a CH3 group. At the same time, secondary methyl alcohol, you can see a diagram over here. One secondary methyl alcohol. You have CH3 attached to alpha carbon. Below we have an R group. On the left-hand side, we have one H. If an alcohol has 2 alkyl groups attached to the alpha carbon, it becomes secondary. But from these 2 alkyl groups, if one is a methyl group, this becomes a secondary methyl alcohol. And the last one, ethanol. Structure has come over here. What is special about this? Ethanol is the only primary alcohol which is going to produce iodoform or triiodomethane. And then we go to the second importance. What is it? It helps to form carboxylic acids with 1 carbon less than reactant molecule. Again, it helps to form carboxylic acids. All this time we didn't see carboxylic acid formation. No, that we didn't see, we didn't look at it. But see, it helps to form carboxylic acids with 1 carbon. Of course, in all these reactions, carbon number decreases by 1, and we are very much familiar with this. I can explain this observation by taking this phenylethanol. We saw this earlier. Phenylethanol can undergo iodoform test, making sodium benzoate. If you don't remember this, you can go back and see the example we discussed. This was discussed under the very first category, methyl ketone. But then I'm talking about the second importance to make carboxylic acid. I don't see carboxylic acid here. Actually, we had to convert this sodium carboxylate into carboxylic acid. How can we do it? However, a dilute acid must be added to the reaction mixture after heating with sodium hydroxide and iodine in order to convert the sodium carboxylate form to carboxylic acid. Now here, look at this product. This is a sodium carboxylate acid. It's a derivative, or you can say a derivative of carboxylic acid. Or simply we can say it's a sodium salt of carboxylic acid. Is far better. Now here we have a sodium ion attached to carboxylic acid, carboxylate ion. If we can find out, or if we can pull this sodium plus out and replace with a hydrogen atom, it is going to give us a carboxylic acid. So simply add an acid, probably HCl. HCl will help sodium to go out and hydrogen will creep in. You add a dilute acid, you get benzoic acid. Remember, children, this question, the last thing I discussed over here, if comes in an exam, many children go wrong. Not that many children go wrong. What happens is many children find it really difficult to recollect this subject area. This knowledge always is forgotten by children, because when it comes to formation of carboxylic acid, many of children who do the exam think Maybe it's an oxidation of an aldehyde or a carboxylic acid. You don't even think about hydrolysis also. So mainly because this benzene comes in this structure, one might get it totally wrong if you don't think well. So remember, this is a really important point many children go wrong. Plus, all the reactions I discussed in this so far are going to be very, very commonly occurring questions in papers, both in ACE and A2. So you got to read these videos several times if you have not got the idea clearly, and try to be familiar. And again, I'm going to tell, you can go back to the beginning of the video and get the URL for the video 1 and video 2 on the aldehydes and ketones reactions, and complete the aldehyde reaction series before you go to exam. Not one day before the exam. Please go through this several times before the exam and be familiar. And it's all about becoming familiar when it comes to organic chemistry reactions. I think that's it there for you today from me. Thank you very much for learning at EasyCamp. Have a good day.